Okay, so total with ace of spades. And what's our denominator going to be here? What are the total number of hands that have the ace of spades? How many of those are there?
So there's going to be, you have to choose, you have to have the ace of spades, and then you have to choose all the other cards.
Okay, so how many is that? How many choices do we have?
So we just have one choice for the ace of spades,
Okay.
and then we're going to have 51 other cards,
Okay.
and then we have to choose 12 of them.
Very good. 51 choose 12 have the ace of spades, so that's on the bottom. Now on the top is a little tricky. And we're gonna have to we're gonna be real thoughtful about this. How many have more than one ace? How do we figure that out? What can we do?
Maybe we could make cases with 2, 3, and 4 aces.
We could, but I want to try to find a different technique. So we did the case-by-case counting last time. So let's try to find a different idea here. You have a different idea?
Yeah, we could use complementary counting.
Okay. What is complementary counting?
So that's counting what you don't want. So in this case, we'd count which hands have the ace of spades as its only ace.
Ah, okay. And how many of those are there?
So that's 1 times 48 to choose 12.
Okay, so on the top we could have a 48, choose 12. So this is the number of hands that have the ace of spades and no other aces.
But then we need to subtract that from the total.
We have to subtract that away from the total. Very good. 51, choose 12. Minus 48, choose 12. So it actually, this is even easier than we could have done this on the last problem too. But it's it's actually easier to count the ones that have no further aces because you know where they came from.
Yeah.
They came from those 48 cards, and you just subtract that away. And when you do this, you get, let's see, I did it in Mathematica, I get 11,686 over 20,825, which is about 56.1152.
Yep. That's what
That's the numbers on paper.
So there you go. So it's very interesting. So I think with the dice from the project we did yesterday, it's actually illuminating and it helps you see how you can have more cases here.
Yeah.
And then we can just do the calculations and we can replicate their numbers.
Cool.
But how would you explain this? Why do you, let's start with you, why do you think there are more? Actually, let's go to the last video.